Hi, my name is Vladimir Horikov, and this is the course about domain-driven design and working with legacy projects. In this module, we will look at the existing legacy project. I will guide you through its problem domain, and we will talk about the underlying code and the database. The application we'll be working on is a package delivery system. As its name suggests, this system allows you to keep track of packages for delivery. There is a workflow each of the deliverers should follow. First, you need to create a new delivery. Here, you choose a customer and specify the destination address. After you do that, the delivery is created and remains in status new. Then you can edit the package by selecting products to deliver and calculating the estimated cost of delivery. This will bring the delivery in the ready status. Finally, you can send the package to the customer. This will change the status of the package to in progress. This is how the application itself looks. You can see here a list of deliveries with their customers, statuses, and destination addresses. You can create a new delivery. For that, you need to select a customer and write down their address. Let it be some street, suite 300. The city and the state is Washington, D.C., and some zip code. You can see the new delivery has appeared in the list with the new status. Now we can specify what we are going to deliver by editing the package. Here we can choose up to 4 products and select the amounts for each of them. So let's say that the customer wants the best pizza ever in the amount of 3 items. And let's say that they also want a fridge. Saving the selection. As you can see, the delivery has been moved to the ready status. We can open the same package once again and ask the system to recalculate the delivery cost, like this. The cost is $160. Finally, after all the preparations are done, we can mark the package as in progress, meaning that it's on its way to the customer. The application is rather simple, as you may see. Let's now look at the underlying codebase and the database. We'll start with the database. And just as in many legacy projects, it's awful. Right from the start, you can see these weird table names. They are shortened and all in caps. If we look at this table, which represents deliveries in the system, we can see that the column names are no better. It's hard to grasp the meaning behind these cryptic titles, but that's not the worst part. Renaming a column wouldn't be that big of a deal after all. There are other shortcomings in this table too. First, all columns, except the column that represents the primary key, all of them are nullable, which is a red flag because normally you would have both nullable and non-nullable columns in your tables. This suggests that the current state of the table structure is incorrect and doesn't represent the real data model. Alright, let's now try to map the columns to what we saw on the UI. The cost column is this one. This is the number or ID. This is a reference to the customer, and this one stands for the current status of the delivery. But, as you can see on the screen, we can specify 4 products with the amounts for each of them. However, in the database, we can only see 2, product line 1 and product line 2, and their respective amounts. Where are the other 2 products? It turns out that there is a second table with the information about deliveries. Here it is. And there you can see the missing 2 products, product line 3 with its amount and product line 4. So the information about the products is spread across 2 tables, and the application gathers it when it shows this window to the user. But the bigger problem here is that the delivery table is not normalized. You shouldn't have the products inlined into the parent table. That's database design 101. What you need to do instead is you need to have a separate table with product lines and set the relationship between the 2 as one-to-many, meaning that for each delivery you will have multiple rows with the product line and its amount. This will allow you to get rid of this duplication here, where the columns are basically the same, with the only difference between them being the number of the line. This normalization would also help deal with the other problem with the current design. As you can see on the UI, the application allows for only up to 4 products at a time in a given delivery. And the reason for that is that the underlying database can only handle 4 lines. So if the user wants to create a delivery with 5 lines, they will need to split those products in 2 separate deliveries instead. And it seems that at some point in the past, the application allowed for only 2 products to be delivered at a time, because, as you can see here, the main delivery table only handles the information about 2 of them. It seems that there was a change request from stakeholders to increase that limit, but instead of refactoring the whole thing and extracting the product lines into a separate table, the developers just extended the existing one. And they did that in the worst way possible, by adding a separate table, delivery 2, with another 2 product lines in it. So the limit was increased, but if the stakeholders would ever want to increase it again, the developers will have to again modify the structure of this table. Another issue with this table is that the product amounts are all represented with the char of size 2 data type. They should all be integers instead. The application code simply needlessly converts the strings to and from the integer type, because if we look here, the amounts are currently handled by the up-down control. But that is small potatoes comparing to the previous issue. Alright, that's it about this screen. Let's look at the screen for adding a new delivery. The customer field is represented with this CSTM field. It's a reference to the customers table, which we'll look at in just a minute. And as I mentioned earlier, the STS column is for the status of the delivery. But where is the information about the address, the street, city and state, and the zip code? We have a table here for all addresses. It pretty much mimics the screen we just saw. Here's the column with the street information, city and state, and the zip code. And it also has a link back to delivery, which means that the delivery and the address tables are related as many to one. In other words, for each delivery, there can be multiple addresses. But if you look at the UI again, there is no ability for us to add another address to the delivery, which means that the relation between the two should be one-to-one instead. So what we have here is another issue with the way the tables in the database are structured. Instead of having a reference from the address table to delivery, there should have been a reference the other way around, from delivery to address. Or alternatively, the address could have been inlined in the delivery table. Also note the inconsistencies in the column naming. Some of the columns have this CLM postfix and others don't. Besides, the primary key column in this table is named differently than in the delivery one. It's called ID column, whereas in other tables, the primary key is called number column. And of course, the city and state shouldn't be stored in a single column. That is failing to adhere to the first normal form, plain and simple. Let's look at this table now. It contains information about customers, and the name P is probably related to the word people. But no one really knows for sure because the original developer quit long time ago. The columns you can see here are the name and 2 references to the address table. So what you might get from reviewing this table is that each customer might have 2 addresses. Maybe one of them is primary and the other one is secondary. But if you look at the data this table contains, there is no one customer with the second address filled out. So this second column is orphan. It's still there because no one ever bothered removing it. Alright, and finally there is the product table. Each product has an ID, name, description, and weight. Note that for some reason the ID column is not marked as primary key. Also, having the name and the description stored as fixed-sized strings means that all strings in there will be padded with trailing spaces to match their size. And that means that in order to properly display those strings on the UI, the application has to trim them every time it loads the products from the database. A better way would be to have this data stored as varchar or nvarchar, which allows for a variable string length. Another strange design decision here is that the table has 2 columns representing the weight of the products. One of them is weight in pounds and the other one in kilograms. And if we look at the data inside, we can see that for any given product, there is data in one of the columns or the other, but not both, which means that some of the products have their weights encoded in pounds, while others in kilograms. A better solution here, of course, would be to convert the weight to one of those units of mass and store them uniformly for all products. But it's a legacy project, you can't have high expectations here. Alright, that's all tables we have in our legacy database. Let's create a diagram with them and summarize what we just saw. Here's the diagram. As we discussed earlier, the most obvious thing here is naming. The uppercase is everywhere, the names themselves are cryptic, and there is no single naming convention. Some of the columns have this CLM postfix, others don't. Another issue is that all columns, except for identifiers, are made nullable. That's a lazy way to approach database design, as it doesn't give information about which fields can and which cannot be empty. Next, there are no foreign key constraints between the tables. For example, the delivery table refers to the customer one with this CSTM column. But there is no constraint to actually enforce this relationship. And so it's possible to delete a customer that is referenced by delivery, which would bring their delivery to an inconsistent state, because we would lose the important piece of information about it. There also are a few other minor issues, like for example the fact that all string fields are represented with fixed-size char data types and have information about both the city and the state of an address stored in a single column. The most important drawbacks, however, are related to the relationships between the tables. First of all, the information about product lines in a delivery is inlined into the delivery table itself, which means that the application can have maximum 4 products in a single package. It would have been better to introduce another table instead, like this, and get rid of all those fields in the delivery table. But we have what we have. Secondly, data related to the deliveries is spread over 2 tables for no good reason. It doesn't add any benefits and only complicates the work with the deliveries, as the application code needs to manually assemble that information from those 2 tables. And finally, the relationship between the delivery table and address is one-to-many, meaning that one delivery can have multiple addresses, whereas in the reality, you cannot specify more than one address for a given package. So the relationship should be backward. A single delivery should have only one address. You can find the application code on GitHub or in the exercise files on Pluralsight. If you prefer GitHub, head over to my page and navigate to the Legacy Projects repository. Alternatively, you can use this short link. There are currently 2 folders in this repository: Initial, which contains the initial version of the source code, and ACL, which contains code with the anti-corruption layer from the next module. By the time you watch this, there will be another folder containing code with a synchronizing anti-corruption layer, which we'll be discussing in a later module. The database script is also here, in the initial folder. Alright, so let's take a look at the application code. We will not be working with this code much, so I will not dive deep into it. As you saw earlier, it's a desktop application. It's written using WPF. The codebase itself is actually not bad. It's definitely not as awful as the database. Here's, for example, the view model that is responsible for editing the product lines in a package. There is some data the UI binds to, such as product's name and amounts, commands to change the products, loading that data from the database, and saving it back when clicking on the OK button. The DB helper class uses plain SQL. The SQL is quite hard to read, but it's mostly the product of the messy database rather than the application code itself. This class uses Dapper to execute SQL queries. If this was a real project, I wouldn't consider its codebase legacy. The way I would approach it in the real life is I would continue working on adding new features to it while simultaneously refactoring the database using the migration-based approach. Alternatively, because the project itself is quite small, a full rewrite would be a viable option here. But keep in mind that it's a simplified version. I need to keep a balance between the project size on one hand and its realism on the other. I just would not be able to realistically show you a fully fledged legacy project within the scope of this course. So even though the codebase here is pretty good, let's assume that it's not, and that it is as messy as the underlying database, or even more unmaintainable. Therefore, working on the existing codebase is not an option for us. And let's also assume that it's much larger than what I showed you, and so rewriting it from scratch is not an option either. So what do we do when we cannot maintain the existing codebase due to it being a complete mess, and we cannot rewrite it either, because that would be a several years worth of effort that the stakeholders would never approve? That's what we'll be discussing in the next module. And by the way, if you want to learn more about refactoring databases using the migration-based approach, check out my Database Delivery Best Practices course here on Pluralsight. In this module, you saw the legacy system we'll be working on throughout this course. The underlying database is a mess without any concern for data integrity, normalization, or readability. The application code is actually not bad, but for the purpose of this course, we will assume that it is bad and unmaintainable. We will also assume that it's large enough so that a full rewrite is not an option for us. Note that although the application is a desktop app and quite small overall, the principles and techniques you'll be learning in this course are applicable to any type of a legacy system, be it an API, a web application, or a desktop one like ours. In the next module, we will start introducing new functionality to the project. You will learn the concept of anti-corruption layer and the bubble-bounded context, and we'll see how to maintain good separation between our new code and the existing legacy mess.